Alright, we got examples of opaque filament and somewhat transparent filament. And it'll have this like structure right there that's a elevated modeled in raft. So you want to break it off, but you want to make sure that, because it's semi-fused, that it doesn't damage this piece right there, which is the pall. So just kind of wiggle it side to side to see how it's taking the pall with it. So once you get there, just break it the other way. There we go. And we'll see that this is undamaged and it's pressable. And you can just throw these away. And we have some printed caps of various colors, because why not? And for comparison, we'll put in some real Dram pill bottles. Basically, this works by having this pawl here and these teeth, and it's a one-way ratchet. In order to open it again, you have to pull down in order to move the pawl out of the way. And it's called the CRC, or it's an implementation of a CRC, child resistant closure, where you have to do multiple steps in order to open it. You can also bypass the child resistant closure mechanism by, instead of closing it this way, turning it this way, because there's threads inside here and threads on top of here. Right? So for adults who have issues using the protective system, or if they just don't want to, they have options to do something else to close and open it. It's a little looser, but it has the same mechanism. The teeth can be adjusted, but this is fine. It's a little gnarled in the bottom, but just don't look at the bottom. And it is a little tough to pull down. It's not like, what is this? Polypropylene. You know, it's not as flexible as a polypropylene. You may deform it and have to use a little extra force, but it does work the same way. And the same with the reverse side threads. Right? Same here with the larger pill bottle. These are compatible to the point where they're interchangeable. So, you know, if we take the real bottle, we can use the 3D printed cap. Same for the reverse side threads. And the other way around, real cap, 3D printed bottle. And we'll show that with the larger one too. Alright, looking at the Blender file, first thing is that this is Blender 4. So the first thing to notice is there is this params object here. It's just a text, but that is where in the object custom properties that I store, you know, various parameters, so you don't have to run around the entire document to find those parameters. You can just go to items here after you selected it and see it in the overlay here. And then here are some presets for it. If it's not mentioned, then it's just leave it default. So if we leave it at 0, 0 for the height mod and the radius modification, then that's just going to be the basic medium-sized bottle, and then we can shrink stuff down for the smaller size bottle. So let's see, height mod, -1.645. Then it takes a while to recalculate the geometry after setting one of these things. It is kind of a slow, laggy document. So if I wanted the small one, there we go. And that's mostly done with shape keys that are all over the place that are then driven by the values in params. Let's say if I wanted to export this, there would be 3 different STL objects that I need to worry about. And they start with ASM underscore. So the cap, and then modeled in raft and bottle here should be exported together. So if I go to export STL, just select those two, selection only, and save them out, join together. You could try to make a larger radius, but there is like a range of what's feasible here. So this is centimeters here. So if I say 4, so that's going to make the diameter 8 centimeters larger, or 80 millimeters larger. Yeah, and then we have a tub, potentially a cookie jar. Let's see what one of these look like. But we do have an issue here where this lever, because the diameter is larger, it's flatter. Before it would be like, this large, and so this part here could go in farther deeper, but now that it's larger, we're not going in as deep, so the ability to pull down the lever is not as effective. And something interesting here about my workflow is that usually I'll just have a bunch of modifiers, intermediate objects that do a bunch of booleans and stuff, but I've been playing around more with inserting more geometry nodes into my workflow. Just something to try out. So when the radius here is made bigger, let's say if it was that size before and now it's like that size, this is actually the surface here that interfaces with this lever here, comes closer down and gets flatter. And this is an advanced theory called flat bottle theory. It's kind of a pseudoscience that, you know what, we don't need to get into it. It's just there's a limit to how large you can make the radius without needing to address this, which I do not.